Hello again. Thank you for joining us on Space Nuts, the astronomy and space science podcast. My name is Andrew Dunkley, your host, and we'll be chatting about a lot of things today. What came first, the chicken or the egg? Or let's be more specific, the black hole or the star? That is the question. And it looks like the answer might be a little bit of a flip on what we've always believed. We'll also be looking at SpaceX. Of course, they've been working on their latest set of rockets, the SpaceX rockets. They've got one called Starship that's in the testing phase, but they've got plans for an even bigger one. And the news is it could have military applications. What does that mean, I wonder? That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as always, Professor Fred Watson, astronomer at large. Hi, Fred.
Hello, Andrew. Very good to see you again.
Good to see you too, up and about. You've been in the wars lately. You found out what bit you the other day.
Yeah, yes, that's right. It was a tick.
A tick?
A tick, a little tiny insect. And we know that ticks they abound in this district. People sometimes say the northern beaches of Sydney are the tick capital of New South Wales. I knew that. And in fact, I thought it was a tick bite. But then when I started getting other lumps appearing and getting fevers and starting to get really, really crook, I thought it can't have been a tick, but that's what it was.
Wow.
I've had something called rickettsia.
That doesn't sound nice at all.
No.
Yeah.
Otherwise known as spotty fever.
Oh, how horrible! Well, at least they've figured it out, Fred. That's the main thing.
Yep, they did.
Yeah,
took a couple of people about half an hour to work it out.
Yeah, I remember when I was a kid, we went on holidays up to a place called Blackhead, which is a beautiful little beach area. Used to be a sleepy village. Now it's probably been commercialised beyond help. Yeah, really. But we used to go down to the lagoon and catch fish, and go in and out of the bush and the mangroves and all that. And one night, my friend, we were staying at his place, lifted his shirt up and there was a tick buried deep into his abdomen. I mean, it was right in there. Oh, yeah. Horrible things they are. They got it out with, methylated spirits.
That's right. To cool it, you try and freeze it.
Yeah.
So it becomes inactive.
Yeah.
That's right.
Well, it backed out in an awful hurry once that stuff was on it. But yeah.
So that was yeah. Okay, that's something to bear in mind. Since I do have some methylated spirits.
Yeah. Anyway, I'm glad you're on the mend. That's the good news. Now let's get.
Hopefully, I am. Yeah.
Yeah. Let's get on to our first story. This is big news, and not surprisingly, comes from data collected by the James Webb Space Telescope, and it's looking into the early universe. And we've been getting questions about this from our audience because a couple of people have come in and said, look, it doesn't add up. The age of the universe doesn't correlate with those early galaxies. It doesn't make sense. Something else must have happened. And now they've actually been looking into this, and it looks like our audience members who have brought this up are on the money. It looks it hasn't been absolutely utterly confirmed yet, but if they're right, this really turns things around in terms of the early universe, doesn't it?
Absolutely. And I think it's a great credit to our listeners and viewers that they do ask questions that are also occupying, the scientists who are really looking at the history of the early universe. And what's done this is the James Webb Telescope. The fact that, yes, we have observed galaxies which are, we see them as they were when the universe was less than 400 million years old, remembering that it's 13.8 billion years is the age of the universe. That comes from really reliable observations and theoretical background. It's very hard to push it back any further, even though, as you and I have spoken about, some scientists have tried to do that and say, well, the universe must be older. But that's not what the majority of scientists believe. We are pretty hooked on the 13.8 billion year age of the universe. So the problem then is, you see these galaxies, which are, they've got supermassive black holes at their centers and are relatively mature. And so how are these, we didn't think we could get galaxies looking like that with a supermassive black hole at the middle within the first few 100 million years of the universe. So how do you reconcile these? And I think the bottom line is sort of what you've already hinted at. We have tended to draw the inference that black holes generally, and particularly supermassive black holes, are products of the centers of galaxies where there's a richness of stars. And because there are all those stars there, the black holes gobble them up and they become supermassive. But that takes time. And what this new work is doing, and it's being led by some people I know, actually, Johns Hopkins University and in the Sorbonne in France, Johns Hopkins, of course, in Baltimore. What they've done is they've turned that picture on its head, which is to say, well, maybe the black holes came first. And so what they're suggesting is that black holes, and probably big black holes as well, really were formed with the Big Bang itself. So rather than black holes not being there when galaxies form and then accumulating their mass by gobbling up stars after stars are formed, after galaxies have been formed. Rather than that, they're turning it on its head. So what he says, it's actually quite subtle facts, though. So what you've got to imagine is a universe that creates black holes. Now, even people like Hawking were talking about the possibility of primordial black holes that are created within the aftermath of the Big Bang. And maybe we're seeing this theory carried a bit further forward because nobody's ever observed what a primordial black hole might look like.
Yeah.
But the argument that Joe Silk and his colleagues, he's the principal author of this work, a very, very eminent cosmologist, what he's saying is that rather than black holes and galaxies being formed in the reverse order there, galaxies are formed first, black holes inside them are formed afterwards.
Yeah.
Rather than that, it's the other way round. But the subtlety is, and I'm going to quote Joe Silk here, we're arguing that black hole outflows, and by that he means the winds that we know that black holes generate when they're accreting material. You get these relativistic, that means very high speed, winds of material and radiation too, coming from the poles of a black hole. And by the poles, I mean direction perpendicular to the accretion disk, the disk of material surrounding where all the stuff's going in. So they're saying, we're arguing that black hole outflows crushed gas clouds, turning them into stars and greatly accelerating the star formation. Otherwise, it's very hard to understand where these bright galaxies came from because they're typically smaller in the early universe. Why on earth should they be making stars so rapidly? So the idea is the black holes are driving this rapid star formation by these violent winds.
It's quite extraordinary because and as I said earlier, it tips all the previous theories upside down. So what they're basically saying is that the Big Bang happened, and very, very quickly after that, these huge black holes formed, and then they caused the stars to be created at a great number very quickly, which then formed the galaxies. Is that what we're saying?
Yeah, that's right.
Wow.
So a kind of counter-argument you might throw at this is that, well, even with the James Webb Telescope, we can't see any evidence of these violent winds, the jets of material that are coming out of the black holes. But what Silk says is that they're too far away. in fact, to quote him, we can't quite see these violent winds or jets far, far away, but we know they must be present because we see many black holes early on in the universe. These enormous winds coming from the black holes crush nearby gas clouds, turn them into stars. That's the missing link that explains why these first galaxies are so much brighter than we expected. And the article that I've been reading about this, which is on the phys.org page, comments that the young universe, as seen by Joe Silk and his team, the young universe had two phases, in which the first phase was this kind of high-speed jets and outflows from the black holes, accelerating the star formation. But then in the second phase, the outflows slowed down. And so you've got another phase where the gas clouds are collapsing again, still forming stars, but he's actually pointing to magnetic storms in the supermassive black holes as being a cause for that. So you've got two distinct phases of star birth in the very, very early universe, and maybe that will account for why they are brighter than we expected them to be.
This again underlines how amazing the James Webb Space Telescope has been, because we've said all along, once it got up there, it would start opening up areas that we've been wondering about for a long time, and potentially coming up with answers. I suppose we should qualify this by saying this isn't absolute. They've got to do more work to prove that's theory, right. Which they also have to do through the James Webb Space Telescope. But it is starting to look like they've come up with a new beginning to the universe, which is it's pretty astounding, isn't it? If it's true, that's a major achievement.
Yeah, absolutely. It's it'll be really interesting to see how the just how the astronomical community and the cosmology community takes this paper, how they react to it. It's only just come out. The paper, by the way, is which came first, supermassive black holes or galaxies? Insights from the JWST. There you go. And I might. Sorry, go ahead.
Yeah, I'm just saying, and they're saying supermassive black holes came first.
Yeah, they are, yeah. One of the authors is somebody I know pretty well because I've worked in a collaboration with her, Rosie Wise. She was one of the leading members of the RAVE project that I was very deeply involved with in the first decade of this century. Rosie is not somebody who pulls things out of the air or anything. She has her feet very firmly on the ground in terms of the astrophysics and the physics that go into these things. So I think this is likely to be an important, or seen as a very important paper, maybe pivotal in its importance. But by the way, I'm not suggesting that Joe Silk, the lead author, is in any way doesn't have his feet on the ground. He certainly does too. It's just that I know Rosie a lot better, and I know what she's like. She's very, very thorough.
Well, it makes my next question moot, but I was going to ask how you feel about this theory. Do you think it has legs? But if they're as astute as you say, obviously it does.
Yeah. Yeah, these are people with far bigger brains than mine, Andrew, and they're not ones to go off half cock or anything like that. They would have made sure that all their observations and theory tie up together.
Yeah, got the brains the size of a planet, by the sound of it.
Indeed.
Yeah. All right, if you want to read that story, and it's well worth reading, it is on the phys.org website, and it's just it's quite mind-blowing, and I know quite a few people who have sent us in questions will be really keen to read about that, because they've been saying this all along. Something else happened, and it looks like you were right.
Yeah. Yeah.
This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, to another story that has applications or implications that could have a few people going, "Oh, you're kidding me? They're not going to do this, are they?" And that is, of course, we've heard of NASA. We've heard of SpaceX. They're working together, and they're going to try and send people back to the moon in the very near future. But SpaceX is working on something else that has got the military intrigued, Fred. What's happening here?
Yeah, it's as you've said, it's the SpaceX work on the next big thing, if I can put it that way, which has already had 2 test flights, none of which were successful. The second one was nearly successful. It was basically during the separation of the first stage from the second stage that things went wrong. It's called Starship, and I should say that the organization SpaceX is planning a third test flight. Actually, it might even be this month. It's going to be very soon, so we might be reporting on that at some point down the track. The other 2 last year ended in explosions. But what you've got with this ginormous spacecraft is something that can lift up to 115 tons to low Earth orbit.
Wow!
So, you know, the real reason for this work being done is because of Elon Musk's vision to send people to Mars. That's why he's built this spacecraft. It's an enormous thing, Starship, and he's focused on getting people to Mars. NASA, meanwhile, is also focused on Starship. But that's because the upper stage of Starship is destined to be the landing vehicle to put astronauts on the moon for the Artemis 3 space mission, which is, I think it's still scheduled for 2020. I think it's 2026 that it's slipped back to now.
Yes.
Because it will, they need a large vehicle that will set down astronauts and equipment on the moon's surface. NASA has chosen SpaceX's Starship to do that. So that's the focus there. But what we're hearing about now, and this is another news item, once again, actually from phys.org, it is a news item that suggests that the US military, namely the Department of Defense with SE at the end rather than CE, which is what we have, there has been, they presented some work at the Space Mobility Conference held at the Orange County Convention Center. Apparently that was earlier this month. What the Defense Department wants to use it for is point-to-point cargo transfer on the Earth. So not necessarily, not necessarily humans, but at least getting, if you need to get a lot of kit from one place to another very quickly, you can do it in an hour.
Yeah.
If you've got a Starship at your disposal. So I might quote, actually, there's one of SpaceX's senior advisors, Gary Henry. He says, rocket cargo point-to-point is not the reason we're building Starship. We're building Starship to get to Mars. But what we're finding is it's a system we're putting together that has profound impact for national security. And one of them just happens to be rocket point-to-point, which just means using a rocket to get from one place to another. So supplies, possibly, maybe troops one day down the track. But I believe that the Defense Department is very, very interested. In fact, we hear that they began looking at the idea 20 years ago. But because now we've got this spacecraft that is almost ready to go, I wouldn't mind betting that there's a good chance that the next test flight of Starship actually is completely successful. It's the way Elon Musk and his colleagues learn, by breaking things and working out what they need to do to stop them breaking.
He breaks a lot of things.
He does, yeah. But there's an interesting quote here from somebody called Gregory Spangers, who's the chief scientist for the US Air Force Research Lab. And he says, envision a number of containers sitting in a warehouse down in Cape Canaveral. We go to an alert level, we pull them up, you start putting them on the rocket. At each successive alert level, your time to launch shrinks. and shrinks and shrinks until we can get it down to 1 hour. And apparently, the teams that work with Spangers, they've already been making mock-ups of the cargo bay for Starship, trying to work out how you can do that. To me, the thing that is interesting about this, because we're all lovers, not fighters, in the world of astronomy, but I think you could imagine this having enormous humanitarian benefits as well.
Yes,
if you had to get stuff in large quantities very quickly from one place on the Earth to the other. It would probably be a very good way of doing it if you could afford it. That's the thing. But that's the whole, the nub of the matter with Starship is that it's cheaper because it's all a matter of scale. The SpaceX's reusable Falcon 9 rockets have brought the cost down typically of getting something into orbit from $20,000 a kilogram to $2,000 a kilogram. That's a factor of 10.
Yeah.
But Starship will bring it down even more. And so it's really very, very interesting to look at the kind of possibilities. In fact, the figure I've seen, and this is pounds rather than kilograms, $90 a pound to get into orbit. What's that per kilogram? 2.2 times 9 is about 20. Mm-hmm. Sorry, about 200 then. $200 per kilogram. So it's a tenth again. It's come down by another factor of 10.
Yeah, but I think they're talking about it becoming even cheaper in the long term when they build these bigger rockets and have more of them operating. And they're talking about dropping the price to what about $18 a kilo, $20 a kilo,
that's
$9 a pound.
$20.
Yeah, so like you said, but the point I'm getting at is that is equivalent to what it costs them now to transport this thing by plane.
Yeah.
The military transports are about $20 a kilo. And so if they can do it in a rocket, the advantage is time. They do it in minutes to an hour rather than hours to days, which sometimes is the case with standard aircraft transport.
That's right.
We're basically talking suborbital flight, aren't we?
Well, that's right. Sorry, we didn't really make that point. Suborbital flight is what it's about. It's about putting the thing up into a parabolic trajectory, a ballistic trajectory, and bringing it down. With Starship, you'd have to bring it down in a pretty specialized spaceport. Because that's a very, very big machine. And it's not something you can just dump down anywhere. One way of doing it might be to have offshore platforms, things of that sort, Andrew, which is what, of course, they do with the Falcons. But just taking it one step further, this is also in the game plan of Virgin Galactic. They are very keen to use the Virgin Galactic, the mothership and spaceplane system, not just for up and down joy flights, which is kind of what it's doing at the moment, but to do suborbital flight that will take you from London to Sydney in about an hour or thereabouts, less than an hour.
That's just, how bad's the jet lag going to be then? Oh, my goodness.
I don't know. It would be very interesting because, yes.
Well, if you let's say you leave London at midday, it takes 1 hour to get to Australia. The time here would be, let me think, midday. It'd be about somewhere around midnight or 10 p.m. or something like that.
Yeah.
So
it depends on the.
So you're wide awake. You've landed. There's no way you're going to go to bed.
That's true.
Yeah.
You might have to go into suspended animation or something like that.
Yeah, maybe.
But anyway, it is very, very interesting technology and something that I think we might see getting more of an emphasis down the track.
Look, I think it's going to become stock standard in the future. I think this is just going to be normal. They're talking about it as a potential at the moment, but I think the time will come where we're just going to see rockets taking off every day for one reason or another. The other part to this story, though, and people were probably saying, why is the military getting involved? Why do they have to do this? Well, they have to do this because there's another player in the mix, and that's China.
Indeed.
Yeah.
Which is, and China is very much heading in the same direction, I guess, as the US in terms of its capabilities in space. It's got its own space station. It's landed several spacecraft on the moon. The first robotic spacecraft to be landed on the far side of the moon is Chinese. And so they will be doing the same kind of thing, maybe.
Well, I believe they are. I think they are working on this. This is part of their plan. So, the US would probably be very naive to just say, it'll never work. We won't do that.
Yeah.
Because they'll get left behind. In fact, there are some that are saying China is very fast going to take over as the absolute superpower in space if other countries don't get the lead out. So, the race is on.
The race is on, that's right. It's their Long March series, which is really, they've got something called Long March 9, which I don't know too much about, I have to say, which is doing the same sort of thing because the idea is to reuse it, to make it reusable, which is the breakthrough. It occurred in 2015 when Elon Musk was the first one to make a relaunchable booster rocket. But now a lot of players in the space industry are working in the same direction. Jeff Bezos's company, Blue Origin, that's already doing that with their space tourism clients.
Yes, indeed, and this is all going to happen in years, not decades. This multiple rocket, multiple launches, multiple payloads being shot all over the world, probably not far away at all. So it shouldn't come as a surprise, but they've got to get the hardware working properly yet. They're still working on SpaceX and the Starship rockets, but they'll get it. They'll figure it out. I don't doubt that.
Yeah.
All right. If you want to read that story, I believe that one's on phys.org as well. That wraps it up, Fred. Just a reminder too, if you want to listen to Space Nuts Q&A, that will be coming up on Monday. It'll get downloaded to your respective platforms automatically if you're subscribed to us. And if you're a follower on YouTube, don't forget to hit the subscribe button below. Thanks, Fred. We will catch up with you real soon. Fred Watson, astronomer at large, and he joins us every week on Space Nuts. And I hope you'll join us again very soon. We'll catch you then. From me, Andrew Dunkley, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.